Okay, what is a zero energy building? We will look a video and you will know the zero energy building.
Generating electricity to meet an ever-growing demand for energy is a key environmental issue facing the world today. In Singapore, buildings alone account for about 50% of our energy consumption. It is therefore important that energy consumption in our buildings is kept as low and as efficient as possible.
How do we reduce our energy use? How can we produce more electricity without polluting the environment?
To address these questions, the Building and Construction Authority, or BCA, embarked on the Zero Energy Building Project. The project involves taking an existing building and
This project is retrofit from an existing building. The meaning is the building is an old building, but the Singapore government to replace and retrofit the building to become a zero energy building. So this is an existing building to rebuild, retrofit, become a zero energy building. So it's a retrofit building. So change all the roof by solar panel.
retrofitting it into a super energy efficient showcase for advanced green.
And this is a light ship. That means that the sunshine, the sun energy, do not directly get into the so you will look. This is sun safe. It can prevent the heat directly get into the house. And this is a reflection. We mentioned before the reflection and the light reflection inside the house, so that the inside become very bright.
Building technologies.
The Zero Energy Building is BCA's flagship R&D project on energy-efficient solutions for buildings in the tropics. Together with our partners, BCA is taking the lead in this project as part of our efforts to promote green buildings in Singapore. Given the very ambitious zero energy targets, this
is the construction to put the solar panel on
was a very challenging project. But what makes it even more challenging is that it is the retrofitting of an existing building.
So it's a retrofit from an existing building.
Now that makes it not only the first of its kind in Singapore, but also the whole of Southeast Asia. Besides having an unfavorable east-west orientation, the existing layout and the conditions of the building did not make it easy for works to be carried out and for new technologies to be integrated into the design.
Located within the BCA Academy, the Zero Energy Building serves as a live test.
This is because this building is a kind of research building. So we have many sensors to monitoring the efficiency of the energy.
For energy efficient building designs and technologies. It is a center for innovators to exchange information and promote new ideas, new technologies, and new materials.
What's a zero energy building?
The Zero Energy Building is a super energy efficient building that generates enough solar power to meet its much reduced energy needs. It remains connected to the national power grid, supplying energy to the grid when more energy.
You will know the energy is the solar power generation and on the roof, and it can send back to the grid. The energy can send back
Is produced than needed, and drawing energy from the grid when not enough is produced. More active solution. power to meet its much reduced energy needs. It remains connected to the national power grid, supplying energy to the grid when more energy is produced than
So the energy produced from the solar energy, it can supply for the grid.
needed, and drawing energy from the grid when not enough is produced.
And therefore, if the energy need is from the grid, so the solar energy sent to the grid, and the energy consumption from the grid. So this is a connect to the grid.
More importantly, to achieve zero energy, we must first reduce our energy needs. In the zero energy building, energy needs are reduced in two ways: passive design.
Passive design is like the energy, reduce the energy consumption, such as insulation and light, using the daily light, use the sunlight to let indoor become bright. So saving lighting and saving energy consumption, saving cooling system, we call this passive design. Something like that. You use the insulation material, you use the lighting technology, and the active solution is like you use solar panel or wind power. We call this is active solution.
And active solutions.
What's passive design?
In passive design, we are tapping on nature's power for.
So for you on the roof or somewhere, you use this kind of plant, you can reduce later the city, later the environment become that it's not so hot, so you can save cooling
Energy needs. Nature's power is abundant and we don't have to pay for it at all. Passive design helps to reduce the capacity of building services, saving on capital and electricity costs. With this passive design, we can expect to see
many in Paraguay. You may look at some building covered by plant because it is very good for insulation to saving the cooling.
reduce heat entering the zero energy building, thereby reducing air conditioning capacity.
And on the roof, you can have many plants to reduce, to let the roof become more insulation. So you can save in the cooling indoor.
Natural daylight will also help to
And the daylight, we call it natural daylight. We use the lighting technology. The sunshine come from here and then reflect back inside the room. So that the indoor become bright. So we call this natural daylight. We can save lighting energy.
cut down on artificial lighting significantly.
So you will look, all the lighting is from sunshine, not from electricity. So you can save in electricity because you use the lighting technology, the light from sunshine.
But electricity will still be needed for many of our
So you will look, the office is the lighting is a natural light, is from sunshine because they use a reflecting technology. So the lighting can get into the house, and they use also the lighting here is from sunshine. So inside the office, the daytime is very bright. So you do not use any electricity for the lighting system.
activities. When we do use it, we must do so as efficiently as possible. Active solutions are energy efficient.
And the active solution is we will do some active method. Something you will put solar panel. So put solar panel is we call it active.
Building systems and equipment that provide for our comfort and function.
By means of the total building performance approach, We not only look after the design of the building, but we also ensure that the management and the usage of the building contribute towards total energy efficiency. This means continuous monitoring and management of the environmental conditions, such as carbon dioxide level and light intensity levels, as well as the occupants' usage pattern management.
But any measures to reduce energy use will only be effective if users are disciplined. We must all each play our part and stop wasteful habits.
The Interministerial Committee on Sustainable Development has set stretch energy targets for the building sector. The zero energy building is a...
You will look at the sun-safe shading system. This is also solar panel as the shading, sun shading system.
prime example of how this can be achieved to the fullest extent, even for an existing building. The building sector will need to do our part to reduce carbon emissions. The zero energy building is one important step in this direction. BCA will continue to step up R&D efforts in this area and work with our industry partners to turn our vision of sustainable development into reality.
Now I know what a zero energy building is. One day, I hope I get a chance to stay in a zero energy home and study in a zero energy school.
The Zero Energy Building is an important milestone and model for the Singapore building industry as it strives towards greater environmental sustainability.
Yes, and continually we will look. Tree House is also called zero energy building in our campus in Taiwan, National Taiwan University of Science and Technology. And that's we also this house is also called zero energy building, and I will show you the video. This tree house is interview by Discovery Channel. So in Discovery Channel, you will look at this tree house. The tree house, this is a normal glass here. And this is our solar glass here. And this is it's a low E glass. It's insulation glass here. And this is my glass, solar glass. And this is normal glass. So we have three houses to compare the energy consumption, energy efficiency. This is the structure of our solar glass. This is a semiconductor here. It can generate solar power. This is the reflection layer here. When the sunshine comes here can generate solar power. And the come here is a reflection back. It can generate solar power second. So it generates solar power 1, and the reflection back generates solar power second. And inside the glass we have 2 air space. Can get a very good insulation. And also we have a reflection film here. It can also reduce the heat penetration. So these 2 layers, it can transfer the sun energy, become solar power. And here it can reflect back the sun energy. So we can assure indoor is very cool during the daytime, during the summertime, very cool. you will look. This is the originally sun energy, and after the transfer to solar power, like this, and reflect back the sun energy. So when the sun energy get into the home, become very fewer. So that means it can generate solar power and also reduce the cooling system, reduce the consumption of cooling system. This is our control of the energy supply. This is the first house is a normal glass house. During the summertime, the indoor temperature is 29. So it's very hot because we set the cooling system automatically start from 28. So the indoor temperature is very high, up to 29. So the cooling system automatically turn on. Yeah, and we will look inside. And this is a meditation system. Meditation system. So it's closed. And indoor we have a fan system. Is to let the air circulate. We look, the door is closed, so the meditation system closed. And the cooling system automatically turn on due to the temperature indoor is higher than 28 degrees. It's 29 degrees, so the cooling system automatically. This is insulation glass. There are some this kind of glass in Paraguay also. It's a very good insulation glass. And because the indoor temperature is 28, it's also you need to turn on the cooling system. So the meditation system closed. Now you will look the cooling system turn on because temperature is 28, so the automatic turn on the cooling system. Now we will look at our solar glass house. This is a solar glass here, solar glass here. So you will look the indoor temperature only 26. So we don't need to use cooling system. We just use the meditation system. Meditation. We do not need to use cooling system. And also the fan system. The meditation system turn on. The temperature is 26. We don't need to turn on the cooling system. Okay. And then this is final result. Final result for the normal glass house. You need 3 kilowatt hour to cooling down the to let the house become comfortable, cooling down. You need 3 kilowatt hour. For the low glass house, insulation glass, you need 2 kilowatt hour. And for ours, heat insulation solar glass house, you just need 1.3 kilowatt hour for energy consumption. But it can generate 1.6 solar power. So 1.6 solar power can supply the 1.3. So we still have a 0.3 energy can send back to the grid. So you will look the difference from this one. The normal glass, the air conditioning, the pink color air conditioning, 1.8. Low glass, 1.3. Our solar glass, only 0.6. The second is the fan. Is the fan system. Is a meditation system. It's 0.6, 0.4, and we are also 0.4. And the time is February in Taiwan is like springtime. So we sometimes we need to use a heater because sometimes it's cold, especially in the early morning or in at the sunset. So the cooling system 0.5, 0.2, and this 0.2. So the total energy consumption combine air cooling, fan system, and the heater. So the normal glass house is a 3. Insulation glass 2. Solar glass only 1.3. But all of these two houses, normal glass, it cannot generate solar power. Insulation glass cannot generate solar power. Our glass, solar glass, we can generate solar power. So the solar power can supply the energy consumption. We still have a 0.3 can supply to others. But for these two houses, no power from solar power. So all the energy should be from grid. So from grid is 3. From grid, this house is 2. But we do not need any from grid. We can send back to the grid, to the 0.3 to the grid. So you may look the difference. The green color is the energy needed. This house needs 3. This house needs 2. We don't need any, and we can give back 0.3. So you can look one day, the energy difference compared to the normal glass is a 3.3 for one day, 3.3 kilowatt hour. So this we call this is a zero energy building because the energy it can supply enough for the energy consumption. The energy supply 1.6, energy consumption only 1.3. So we can send back 0.3 to the grid. So we call this is a zero energy building. So this building of National Taiwan University of Science Technology, for the solar glass, it can, when you put the glass on the house, you can get zero energy building. It's very good.